This is Daryl with Cisco Hands-On Training, episode 24. Today we're going to talk about iBGP, Interior Border Gateway Protocol. That's where we're running Border Gateway Protocol within an autonomous system. In our next session, we're going to put eBGP and iBGP together to show how autonomous systems talk to each other in a real way, complex autonomous systems. In the last episode, we just had autonomous systems with one router each. It's the 19th of March, 2008. This is the network we're going to be working with today. We have 3 routers. All of them are inside our autonomous system 65001. And we are going to create iBGP sessions between the loopback IP addresses on our 3 routers in a full mesh. And we're going to see what that buys us. Here we are in the top router. So I've configured my IP addresses. Let's double check that we can ping the directly attached interfaces. So I can ping the directly attached interfaces on the other routers. Show IP route. I don't have any routing protocols configured at this point. The only routes I have are my directly connected routes. So conft router BGP and then my autonomous system, which is 65001 for all the routers in the lab. No synchronization, which is part of our standard config. And no auto-summary, which is also part of our standard config, although I believe it's default on the iOS version that happens to be on this router. And I have 2 neighbors, so neighbor 172.18.1.1 remote-AS65001. So this is the IP address of the loopback of this neighbor down here, and the remote autonomous system number is 65001, and because my autonomous system number is 65001, the router knows that this is iBGP and will apply iBGP rules. And I have another neighbor 172.17.1.1 remote-AS65001. And let's try to inject our routes into the route table, or into BGP. So I'm going to specify my directly connected networks precisely. So network 172.16.1.1, 255.255.255.255. I'm sorry, I need to mask. T, router BGP 65001, network 172.16.1.1, mask 255.255.255.255, network 172.16.2.0, mask 255.255.255.0, network 172.18.2.0, masks 255.255.255.0, exit, show IP BGP. And there I had 2 routes in there. And with my running config, I configured 3. I configured 3 network statements. Let's see. On 170.18.2.0 mask/24 should work. Show IP BGP. Show IP route 170.18.0 2.0 255.255.255.0. It's directly connected. Network 172.18.2.0 mask. And here it is just a minute later. I didn't make any more configuration changes, but the route eventually appeared. So maybe BGP was just taking a minute before it rescanned to see if it should advertise the route. Okay, so all the routes, all that our network statements are configured, our routes are in the BGP table. If I do a show IP route, of course my connected routes still apply, and if I do a show IP BGP sum, I see that my two neighbors that I've configured are both active, and one of the reasons why they're active is because I haven't even configured them on the other router. So let's go ahead down to the middle router and configure BGP on that router. So here we are on the middle router. Okay, the middle router, conf t, router BGP 65001, no synchronization, no auto dash sum, and then neighbor (172.16.1.1) remote dash AS 65001. So that's an iBGP session again, because it's the same. My AS is 65001 and the remote AS is 65001. Neighbor 172.18.1.1 remote dash AS 65001. And let's inject my routes. Network 172.16.2.0 255.255.255.0 mask 255. Network 172, I have to repeat that, 16.2.0 mask 255.255.255.0. And it would help if I spelled network correctly. I can't backspace, so let me type again. Network 172.16.2.0 mask 255.255.255.0. Network 172.17.1.1 mask 255.255.255.255. Network 172.17.2.0 mask 255.255.255.0. So at this point I believe I have BGP fully configured, and I've done what I remember to be in my standard config, which includes no synchronization and no autodash summary. And I did that from memory, which is very error prone. So in production, you really want to have a standard config written down, and you want to refer to that and use that when you're configuring your routers. Let's do a show IP BGP sum. And both of my neighbors are still active. 172.16.1.1 BGP is configured on both routers, the top router and the middle router, but it's still active. And the question is why? Well, there's a very important answer to that. The iBGP session runs over, well, all BGP sessions run over TCP port 179. The iBGP sessions run between the loopback addresses on the routers. So that means that the middle router needs to know how to talk to the loopback address of the top router, and frankly, since you're in a full mesh, all the loopback addresses of all the routers in your routing domain, whether the routers are directly connected or not, before BGP even works. Let's look at our route table. Show IP route 172.16.1.1. The subnet's not in the table. The middle router does not know how to talk to the loopback of the top router, so of course the BGP session fails to establish. So BGP is not going to be operational in this autonomous system. BGP is not going to be operational here until we figure out how until our routers figure out how to talk to each other's IP addresses. Which means that we need to use a different routing protocol in order to have the routers talk to each other. Well, how can that make sense? I thought the point of the routing protocol is to allow the routers to talk to each other. Well, BGP's purpose is to give routing information, to share routing information between different autonomous systems. Within an autonomous system, you need to use a different routing protocol, a interior gateway protocol, such as OSPF or ISIS or RIP or EIGRP to exchange routing information. You need to have all of your routers need to be able to talk to each other within your autonomous system, so that way your loopbacks can talk to each other, and then and only then can you run BGP inside your autonomous system. And the real purpose of the iBGP inside the autonomous system is to forward the routing information that you received from one exterior autonomous system throughout your routing domain, throughout your autonomous system, and then pass it on to others. BGP is designed to share routing protocol information between autonomous systems. Within an autonomous system, you need to use something else, a routing protocol designed for it. So in this case, we need to actually, in order to get iBGP to work inside our autonomous system, we need to actually fire up OSPF. Or some other, we could pick another routing protocol. Let's fire up OSPF. Conf T, router OSPF 65001. And network, let's use the simplest possible OSPF configuration. 0.0.0.0, and then don't care bits, 255, 255, 255, 255, area 0. This will turn on OSPF on all of our interfaces with all of the interfaces assigned to area 0. And let's do that on the top router. Conf T, router OSPF. Actually, OSPF uses a process ID, so I can make it router OSPF1. It doesn't have significance outside the router, even though on the other router I configured router OSPF 65001. Network 0.0.0.0, 285, 285, 285, 285 are the don't care bits. Oh, and I need to specify an area 0. And note how fast that OSPF message came up. We went from loading, we found our neighbor, went from loading to full, less than 2 seconds. I mean, that was very fast after I hit return after configuring OSPF. Show IP OSPF neighbor. My neighbor is up and it's in the full state. Show IP route. And I have 2 OSPF routes with an administrative distance of 110. One of them is the loopback, and one is the /24, which is the one is the loopback, and then one is the /24, which is the serial link down here. Show IP BGP sum. Let's see if my BGP neighbor came up. My BGP neighbor is still active here. Let's. I'm going to pause for a minute and see if it comes up by itself. Okay, the neighbor has not come up by itself, and I remembered why. And this is one of those, I forgot something, and this is a good reason to have that standard config. So let's look at our config, and I'll talk about the problem here. In fact, let's fire up some debugs and see if we can figure this out. So we've configured our neighbor. So debug IP BGP events. And again, debugging is sort of risky in production. If you end up doing a debug which can result in a large number of If you do a debug which can result in a large number of messages, it can lock up your router or cause your router CPU to go to 100%. And let's see, BGP import timer expired. That's something else. That's, as long as we're here. Oh, let's see, we got some messages. BGP scanning. We're just scanning to see if we have any routes to send. And debug IP BGP. I'll turn on BGP debugging by itself. So now if I do a show debug, yeah, here's the debug that was interesting that I found. 172.17.1.1 open active, local address 172.16.2.1, and then BGP neighbor 172.17.1.1 open failed, connection refused by remote host. So my router here at the top tried to initiate a BGP connection to 172.17.1.1, and the connection was refused by the middle router, and the question is why? And the answer, the clue to the answer, is right here. The local address is 172.16.2.1, which was not what I intended. I intended to initiate the iBGP session from the loopback, because in iBGP it is best practice for all the BGP TCP sockets to go from loopback to loopback. But instead, the router looked at the route table, found that the interface that was closest to the destination was the serial 0 interface, and so it picked the serial 0 interface IP address as the source IP address for this BGP connection. So on the middle router, it was expecting to receive a BGP connection from 172.16.1.1, and instead it received a BGP connection from 172.16.2.1, and so it, because it received it from that IP address that was not considered a neighbor, it refused the connection, and that's why the open failed. BGP open failed, connection refused by remote host. So I turned off my debugging, and to fix it, I needed to specify that the source IP address for all my iBGP sessions would be the IP address of the loopback 0 interface. So I went into router BGP 65001, and neighbor, for each of my neighbors, neighbor 172.17.1.1, update dash source LO0, and neighbor 172.18.1.1, update dash source LO0. And that was on the top router, and then on the middle router, I needed to do the same thing, router BGP 65001, and then for each of my neighbors, I configure my update source to be loopback 0. And now you can see that one of my neighbors came up. The middle router is now BGP peering with the top router. Let's look at that BGP peer. Show IP BGP. Show IP BGP sum gives me the status on the neighbor, and you can see that one of my neighbors has now, I've been pausing a bit, so one of my neighbors has now been up for 6 minutes. The other one's active because on the bottom router I have not configured BGP yet. Let's look at the BGP table. Show IP BGP. Give ourselves a little bit more room. Show IP BGP, and you can see here's the different subnets that I'm learning via BGP. There's 5 of them. 172.16.2.0, so there's 5 subnets. And for some of them, the next hop is the loopback address of the top router. and let's look at the route table. And the route table does not have any BGP routing information in it at all. It only has OSPF. And the reason is because now I'm learning these routes via OSPF and via BGP, but I'm learning it via iBGP. And iBGP has an administrative distance of 200. OSPF has an administrative distance of 110. So OSPF is more believable than iBGP. In addition, our BGP functionality, in order for these routes that we're dealing with here are routes that we need in order for the BGP neighbor session to work. So it'd be sort of silly to learn the route to, say, a loopback address on another router inside my autonomous system via BGP when you need to know how to get there anyway in order for BGP to even work. Let's go ahead and configure BGP under my bottom router here. Conf T, router BGP 65001, no synchronization, no auto-sum, and neighbor 172.17.1.1 remote-AS65001, neighbor 172.17.1.1 update-source LO0, neighbor 172.16.1.1 update-source, neighbor 172.16.1.1 remote-AS65001, neighbor 172.16.1.1 update-source LO0. Oh, and of course I need to configure OSPF here in order for this to work. So conf T, router OSPF1, network 0.0.0.0, 285.285.285.55 area 0. IP is disabled on this interface. Show command brief. Why is it telling me? Okay, well, OSPF came up. It formed full neighbor relationships with both of the other routers. Show IP BGP sum. And BGP is now up with full neighbor relationships. Show IP BGP. I'm receiving the BGP tables. And then if I do a show IP route, I don't have any BGP routes because the OSPF routes take precedence. And that is it for iBGP. Let's go ahead and review our config and review what we learned. Well, let me talk about one other thing. I keep on talking about how in iBGP we want to the loopback interfaces to form the iBGP sessions, whereas with eBGP we wanted to use the physical IP addresses that are directly connected. And the reason is because in iBGP, let's say that we had an eBGP neighbor on the top router and a different one on the bottom router. The way the route update would come in is the remote autonomous system would send the update to the top router via eBGP. The top router would then send that update to all iBGP peers, and that'd be every router in our autonomous system because because in iBGP you do it in a full mesh. And then the bottom router would receive that update via iBGP. Because it received the update via iBGP, it would not send it out via iBGP, but it would send it out to any other eBGP neighbors in different autonomous systems. So that's the way it's supposed to work. Now let's assume that this physical link goes down. In fact, we don't even need to assume it. We can do it right now. Conf t int serial 0 shut. The link is down, but within my autonomous system, I still have a path for the traffic to get through my autonomous system and onto the next autonomous system. Actually, since the route is originating from up here near the top router, that would mean that the traffic would be originating from the bottom, come in the bottom router, and then it would have to route over to the middle router and then to the top router. I lost my physical link, but the traffic can still flow through my autonomous system, but the only way the traffic can flow through my autonomous system is if the routing information got from the top router to the bottom router. And since that's iBGP, the only way the routing information is going to get there is if the neighbor relationship is still up. Well, if the neighbor relationship was between the physical IP addresses, then the neighbor relationship would be down right now. Because the neighbor relationship is between the loopbacks, as long as the routers can talk to each other, as long as the loopbacks can talk to each other, the iBGP session stays up. So as long as there is a route within my autonomous system for them to talk, they will talk and exchange the routing information. And we can see that. Show IP BGP sum. My neighbor is still up, even though I shut down the physical link between the two routers. BGP was able to reroute successfully because the loopbacks still need to talk to each other and because my iBGP session is running on the loopbacks. A loopback is a logical interface. It never physically goes down, so it has higher reliability than any physical IP address on any physical interface. So that is why you run iBGP on loopbacks. eBGP is different. eBGP you want to run on the physical interface because if that physical link between the autonomous systems went down, you want the traffic to reroute around that physical link. But as long as the top router and the bottom router can talk to each other at all, you don't want traffic to reroute around this autonomous system, which would be the effect if the iBGP session went down. Okay, so that's why you run iBGP between loopbacks. Take a final look at our iBGP config. So router BGP, you put in your own autonomous system. Standard config, no synchronization, no Autodash summary. I have 2 neighbors configured, and this is the way that you do the configuration for the neighbors. The first line of configuration for the neighbor, you say neighbor, blah, and then you give the specific information about the neighbor. So in this case, I have 2 lines of information about the neighbor. The first is required. I identify the remote autonomous system number, and that's an iBGP session because it's the same autonomous system number as mine. And then the second line, I'm saying, hey, I will always want the update source to be loopback 0. And that's how I configured my neighbors. I don't have any network statements on this router. I showed that on the other ones. Okay, that's it for iBGP. Show IP route. One last comment. There are no BGP routes in my route table, and the reason is because I only have one autonomous system here. The purpose of BGP is to route between autonomous systems. Within the autonomous system, you have to run OSPF. You have to run a different routing protocol, an interior gateway protocol, such as OSPF or ISIS or RIP or IGRP or EIGRP. Those are routing protocols designed to run within an autonomous system. And BGP actually needs it to work inside an autonomous system. So we configured, in order to get our BGP to work, we configured OSPF. And then on top of that, once our loopbacks could talk to each other inside the autonomous system, then we enable BGP. And the purpose of BGP is to talk between autonomous systems. So if we had a different autonomous system sending us a route, then with the iBGP we would be distributing that route information through our autonomous system. And we'll see that in the next episode. Thank you very much.